Hi, this is Randy, and we're down to our final testing of our web server. This testing involves using an alias name, a CNAME of www instead of the actual host name of LNX. We're going to check using the www name from internally using our Windows client, and then externally using just a Windows client out on the internet. But I wanted to start by this picture to talk about what's going on here. So when the Windows 10 client goes to type in www.hi.bobstaco.com, what it needs to do is that request goes to DC1. DC1 is running DNS, and DC1 knows the correct IP address for www for Windows 10. So the Windows 10 has a 192.168 address, and it needs to contact the web server running on LNX using a 192.168 address. And that's different than from the internet. So let's see if we can take a look at that. Let me move this drawing down just a little bit, and let's go over to DC1. So this is the server that is providing DNS for the Windows 10 machine, and for all the internal clients. It's a Windows server, and so you can see we've got DNS Manager here installed. You can see we've got just a handful of records here, but the particular record I want you to pay attention to is this one right here. So this is an alias record, or a CNAME, or conical name, and what it does is when this name is given to the DNS server, then what's given back is this. So you ask for www.hi, that's the zone, hi.bobstaco.com. That is found here, and it is then goes to LNX, which we have two records for LNX, and the actual IP addresses that are given back then are the IP addresses for LNX. And for the Windows 10 and the Mac client and everybody internally, they need the 192 address specifically. IPv4. IPv6, everybody needs the external address. Okay, everybody does. All right. So internal and external are different. So this is, again, Splitbrain DNS. Now, when we're out on the internet, see if we can bring our drawing back here. When we're out on the internet, what happens is different. So out here on the internet, we need to get also to the web server, but that 192 address makes no sense out on the internet. So what we have is then we have from the internet, requests for www are going to come to this firewall, and then we have the firewall open to allow those requests to come into DNS running on this server. This is, again, an example of Splitbrain DNS, and I take time to explain this because it's a concept that takes a little bit of thought and some examples in order for it to make sense. So I'm actually off-site right now, recording this from off campus, so this is what I'll be doing with my web browser here from off campus. I will be coming then through the internet, and I will be resolving the name www. But what I want is IP addresses that work on the internet. For IPv4, I'm going to want a 198 address. And for IPv6, all I'm going to need is actually the address. So IPv6 is different, and there's no NAT address translation, nothing like that. I know we keep talking about that, but again, to hear things over and over can help. So let's take a look at this this is the Windows 10 machine in the virtual world. So on this Windows 10 machine, if I open a command prompt and I ask let's just use NSLOOKUP. If I say with NSLOOKUP I want to know about www, I want you to notice that it gives me the correct IPv6 address, which is, again, no network address translation, but it gives me this internal IPv4 address. And that would be the same if I ask it for www or www.hi.bobstaco.com. Okay, same thing. Now, if I look at DNS that's handling the outside world, let's go do that here. So I'm into YAS, and again, this is our Linux server, and it's hosting DNS for the outside world, the other DNS server. And we go to zones, and we go to look at it, and we go to records. What we see here is very similar to what we saw on the internal DNS server, which is running on Windows. we see a www record, which is a CNAME, a canonical name or an alias name, pointing to the real name, which is lnx.hi.bobstaco.com. So now if I switch, see if I got this set up. Here we go. This command prompt is offsite. This is offsite, and so from here, if I do an NS lookup, okay, I'm getting my local server here, and I ask it for www.hi.bobstaco.com. Okay, notice what I get. I get a 198 address, which is routable on the internet, but I get that same old IPv6 address. Okay, now the last piece of the puzzle here is to look at the firewall. All right, so bear with me. Let's go do that. So now we're back to this Windows 10 machine, and I'm going to take a look at our pfSense firewall. And I mean, I just jumped right in here, but let me start out by looking at NAT. So I have two NAT rules. NAT is only used for IP version 4. It's not needed for IP version 6. And you can see that we've got one from our earlier lab, and that's for DNS, port 53. But I've added another one here for TCP for port 80. And so what it does is it listens on the WAN interface for this firewall, which is the 198. Well, here, let's just go look. It's this address right here. It listens on this address. This is the WAN interface, IPv4 and IPv6. It listens on that interface, and when it receives a request on port 80, it network address translates that to this address, which is internal, 192.168.19.100, and also sticks with port 80. You think, well, Randy, couldn't you just route that like you are IPv6? Well, we could, but we've never had enough IPv4 addresses to do that. So what we're seeing here is pretty much always the way it's done. That behind a firewall you use these private IP addresses, and out on the internet we use public IP addresses which are routable on the internet. So any 192.168, any 172.16, any 10. Address, those will not route on the internet. All right, so we've done all this as a precondition. My video is getting a little bit long here, but I need to show you this stuff. So let's now go. So these are the NAT rules. Okay, NAT port forwarding. Let's go to the firewall, and let's just go to the rules on the firewall. So the firewall, we have a tab for each interface. I want you to see that. And we're looking at the WAN interface. Okay, now we've got a couple rules for DNS, which was a previous lab. But now let's look at the rules for port 80, which is the web server, HTTP. So coming in, we've got this allow rule, and it says it's using network address translation. It's using TCP. And so this rule is tied to the NAT rule. Actually, when I created the NAT rule on pfSense, it automatically created this rule. So this rule was a consequence of creating the NAT rule. And then lastly, this rule here is simply an allow rule. This is a routing allow rule. There's no network address translation here, but it's listening on the WAN interface. That's the tab we're looking at. And when request comes in under IPv6 for this address, the firewall is configured to allow port 80 to this address. So this firewall has two allow rules for IPv6. It will allow traffic inbound on port 53 destined for this is the IPv6 address for our Linux server, and it will allow inbound port 80 to our Linux server for the web server. So while IPv6 is just routed, we still have to have firewall rules that we can enable to allow the traffic to go through. It's a great thing. And I just take time to talk with you about this because it takes a little bit of time to understand, to make sense. So let's see if we can open up a web browser. Do that here. I'm catching that. And so let me just try this here. I'm just going to say www.hi.bobstaco.com. Okay, we got that same. It would be nice if it was a little cooler. When we do this on Internet Information Server, we get a cooler web page. But this tells us. You saw this earlier when we were testing internally. Now the thing is that we don't know, was that IPv4 or was that IPv6 that did that? And honestly, it is a little bit hard to tell. And you can't always do what I'm about to do. Some web servers will not respond to an IP address, but this one will. And so what I've got here, I did a copy and paste. Let me just bring it over here. if I want to specify an IPv6 address, let me open a new tab here. What I do is I put my IPv6 address in square brackets. So I've got HTTP again, and now I'm saying use this IP address, and that is the IP address of our Linux server. And also, we got it to work. So I believe that we've looked at all the pieces. We looked at internal DNS and how that all the internal clients will get to www through using the DNS server running on our Windows box. We looked at external DNS, and we said we have to have name resolution for requests from the internet. And then we looked at the firewall to see what rules the firewall had to have to allow requests from the internet to get to our web server. Now, no firewall is involved internally. Our internal clients, our Windows 10 client, our Mac client, those clients, they don't go through the firewall. That's all handled internally. Okay, I hope this makes sense. And of course, for most of you who are watching this video, you're students and you're in class, and so we have a chance to talk about this, to demonstrate, to do further. But as the project has this part of it where you're on your own, that's why I want you to have this information available. So this video ran quite long, but let me go ahead and wrap it up.